Welcome to the online lectures for software engineering. This course is for information technology students for third year, fifth semester. I will be starting with the introduction to software engineering. So the first thing that we'll be studying today is what is software engineering. Now in here to start, before studying software engineering, it is important to identify what software engineering actually means. Now the software engineering, this word is made up of two different terms, software and engineering. So we'll study separate what is software engineering, and then we'll study the combined definition of software engineering. The definition of software, as we very well know, that software is a set of programs that contains instructions so that you can achieve a specific functionality. If you want some task to be fulfilled, you're going to write some instructions within the program. When the program gets executed, that specific task is going to be fulfilled. That is a software. Whereas engineering it is a process of using knowledge. That is what, before any work that you're going to do, you need to have knowledge of it, and you need to also know the principles that will be used for designing, building, and analyzing the objects. Analyzing the objects means examine the objects. So we know what is software, what is engineering. Now let's study the combined definition of software engineering. SE, software engineering. SE is the use of sound engineering principles. Now in here, from the definition of engineering, we have taken the principles. Now why are we following these principles? We are following these principles in order to obtain an economical software. Now economical software means this is not costly. This is an inexpensive software. An inexpensive software that is reliable, that it gives you accurate results. Accurate, and it works efficiently on real machine, that it gives you the best performance. So software engineering is the use of sound engineering principles in order to obtain an economical software that is reliable and works efficiently on real machines. Now coming on to the course objectives. Now why are we studying this course? Why is this course added within the curriculum? Now this course is added into the curriculum to introduce the basic concepts of software development. Now in here, we are going to learn the few basic things of what is software engineering and how you're going to develop or how you're going to design a particular software. Now in here, you're going to identify process for defining a product. That is, product means whatever you're developing. How you're going to define a product. That is what is the scope of the project. You're going to define that. Now in here, from the scope of the project is going to start from gathering the different requirements. That is what the customer wants within the software. Now in here, from this first step, from collecting the requirements to shipping. Shipping is delivering the project, delivering the product, and maintaining the product. Maintaining means providing updates to the software. So we'll get to know the basic concept of software development, the first objective. Coming on to the second objective. The second objective is to impart knowledge on various phases and methodologies, practices of software development. That is in here, so that you get the knowledge on the different phases. What are phases? Different steps, or you can say different activities that you're going to perform in one particular phase, that is in one cycle. And the different methodologies means the different methods and practices, the different methods and practices that you're going to use within the software development. First, we identified how you're going to develop the software, the basic concept. Then in here, you're adding in here the different methods and practices to the development process. Then the third step is to understand the importance of testing in software development and study various testing strategies. Now in here, we very well know that for designing a particular software, you need to first gather the requirements, you need to make a plan, then make a model, design it. Then in here, at the end, you also need to do the testing part. You're going to identify in here, or we're going to learn in here, why testing is important and what are the different testing strategies or the different testing techniques that you're going to study. That is going to be there within the syllabus. And software quality metrics. That is in here, the software that you're developing, it should be a high quality software. How you're going to achieve this high quality metrics, that is going to be studied within the software engineering syllabus. Moving on to the course outcomes. Now within the course outcomes, the first outcome is define different software development process and their usability in different problem domains. That is in here, what now whenever you're designing a software, there are different processes that you're going to follow, different steps, different test techniques are there. So in here, for each technique, which technique is used and what is the usability when you're going to use some specific technique. You've got one technique based on some specific requirement, or you can say when the technique will be efficient. You're going to learn this. That is the usability in their problem domains. Problem domains means why you're designing the software. The problem is called as a problem domain. So in here, the first one is complete. The second one is explain the process of requirement collection. Now in here, whenever you're designing a particular software, the first thing that you need to identify are what are the different requirements that the customer wants within its product that is going to be developed. This is going to be identified. Now the process of requirement collecting, how you're going to collect these requirements, analyzing the requirements, how you're going to examine what are the different requirements, whether these requirements can be embedded within the project. All of the things will be identified. And then modeling requirements. Modeling requirements means you're going to prepare a model. You're going to prepare a model before before you're designing the main software, so that you identify the different requirements and their features. And this is used for effective understanding and communication with stakeholders. Stakeholders are the people those people that are developing the software. This can be the engineers, the managers. That's the second point. The third one is design and develop the architecture of real world problems towards defining a blueprint for implementation. That is in here, within the first step, we have identified in here the problem domain, why you're designing the software. Now in here, based upon that, we have also made a model within the second step. Based upon that, you're also going to make an architecture. That is within the architecture, you can identify what are the different inputs, what are the different outputs, everything you're going to identify. So for this real world problem, for this problem domain, you're going to design an architecture so that you can have a blueprint of implementation. What is a blueprint? A blueprint is like a complete picture, what are the different components that are going to be there within the software, or how this entire, as you've designed this model, how this model is going to look like within the main software that is developed. The main software, how you're going to implement each and every feature within the software, that is going to be identified. Then the next one is understand the concept of software quality, testing and maintenance. This we have already studied within the objectives also. Then the next is discuss the concept related to risk management and software project estimation. Now in here, you might be wondering what can be a risk in developing the software. Now in here, the risks can be in here. The different risks can be, if suppose by implementing one feature, some specific feature cannot be implemented within the software, or if you're implementing one feature, it is affecting another feature within the software. That can be one risk. Then in here, scope variations. Whatever you're designing, the aim of your project, it is every time it is having a different variation. Sometimes the customer comes and tells that he wants something to be developed. The next day he's going to come and tell that XYZ something else need to be developed. So this is another risk. The other can be poor quality of the code. Your code is very poor, that it can have many bugs in it, and poor productivity, that the software that you're developing, it is not a high-end software, that is, it does not have the best quality. Or risk can be taken as what are the different problems that you're going to encounter while developing the software. It can be based upon the different technologies, it can be based upon the cost. So different problems, how you're going to manage those problems, you're going to learn that. Risk management and software project estimation, that is how much will be the cost for developing the software, how you're going to estimate all of this. Now coming on to the syllabus, this is the syllabus for first unit. Within the first unit, like it is divided into 3 chapters. The first is the introduction to software engineering, process models, and an agile view of process. Now in here, within the first part, we are going to learn the basics of software. You're going to study the basics. What is the generic view of process? What is a framework? The nature of software? What is software engineering? Now, what is software engineering? We have already learned this. Then software myths. Then within the second phase, we are going to study different models. All models we are going to study within the process models. Whereas the last one, it is also models, but in here, these models can embed changes within the software that is being developed. This can have the different changes. That is when the software is being designed. If suppose the software development has started and the customer comes and tells you that he wants some specific change to be there within the software. Now in here, if suppose your software is even at the completion stage, so that those changes that were requested by the customer, those changes can be embedded within the agile process models. So after studying these process models, we are going to study the agile process models. The first unit is divided into 3 different parts. Now coming on to why software engineering is important, why we are studying software engineering. Now in here we are studying software engineering because it is going to enable us to build complex systems in a timely manner. Build complex systems in a timely manner. Now in here, what are complex systems? Complex systems means it is going to have different number of features. It is a bit difficult to design. So in here, you're going to identify how you're going to build those different complex systems in a timely manner. Timely manner means within the specified time frame, within some specified time frame. That is in here, when the customer comes to a developer for building the software, he's got some time period. That is, he wants to launch the project within some specified period of time. So you need to complete that project within that specified time. So the first point is, it is going to help you identify to build a complex system in a timely manner. The second point is, it ensures the development of a high quality software. Now within the objectives, we have studied how we are going to ensure the best quality of the software. We are going to identify that within the later units of the subject. So in here, how you're going to build this high quality software, you're going to learn this. Then the third point is, now now the study of software engineering is important because it imposes discipline to work. That is, discipline to work means in here in software engineering, we are studying the different practices that you're going to follow, or you can say the different tasks or activities that you're going to follow. Now, when you know the different practices and you know a specific order in which you're going to implement, you know how you're going to test them, you know how you're going to model them, you know how you're going to do the coding part. Now in here, when you know each and everything, the order in which you need to do, it imposes discipline in work. So these are the 3 steps why software engineering is important. The next part is, there are a few objectives for software engineering. The software that are developed, those are maintainable, or you can say it has got the software that you're going to develop, it ensures maintainability. And maintainability means in here, first, the software that you've developed, if any changes are requested within the software, then those changes you need to embed within the software. That is called as maintaining the software. Now these changes are based upon the customer's requirement. So software that you're going to develop, it is going to be maintainable. The first objective. The second one is correctness. Now, we very well know what is correctness. Whatever software it is being designed, it should be correctly implemented. Now, in here, correctly implemented in here means it should give you the exact result, the accurate results. Then the third one is reusability. Now in here, reusability is, now whenever you're designing a particular software, it is going to be made up of different components. Now in here, whenever you're designing a particular component, these components, if you're reusing these components to develop another software. So whenever you're designing a software, you should focus upon reusability. That is, if you already have components that is going to do the job, you should take those components and you're going to embed it within another new software. Then the fourth objective is testability. Now testability means you're going to evaluate the software. Evaluate means whether it is giving you the correct result or not. Now in here, testability can be ensured by two ways. That is, in here you can give a wrong input and you are going to see what is going to happen, and then when you're giving a correct input, what is going to happen, you're going to identify that. Now this testing is called as test criteria. So you're going to evaluate the software by means of different test criterias. Then the fifth one is reliability. Now reliability means whenever you're designing a particular software, now in here there is some specific task. Now what that specific task, it should give you the desired function that you want. That means that is reliability. A program can be expected to perform desired function. That is, suppose you want to do addition within the calculator of the system, then it should give you the desired function. Then the next one is portability. Now portability means, if suppose this particular software that is being developed, it should be able to work on different computers, so you can say different operating systems. The software that you're developing, it can be transferable to another computer that can have another operating system also. The software should be portable also. Completely different OS, operating system. And the seventh and the last objective is adaptability. Now adaptability means a software should allow a system and user to be satisfied by making changes to the software. Now in here there is a customer. Now this customer wants some changes to be embedded within the software. So in here, the software that you are developing, it should be able to make changes within itself so that the customer is satisfied. Customer is satisfied by making changes within the software. So these are the 7 objectives. That is the software that you are developing. It should have all these 7 different features. Now the next thing is that the important term that we'll be discussing. Now in here, whenever you're designing a software, there is the customer, or you can say there is a user that is going to use the software. Now this person is not going to develop the software. Who's going to develop the software? The developers are going to develop the software. Now in here you're going to use two different terms for the term customer and developer. The customer will be called as end user and the developers will be called as stakeholders. Now in here, in place of customers within the software engineering, you're going to have the term end user, whereas within the developers, you're going to have the term as stakeholders. Whenever you know the stakeholders means, stakeholders in here, stakeholders means any people that are going to be directly impacted by the development of the software. Now in here, directly impacted means you're going to have a manager, you can have a software engineer, you can have the marketing people. That is, by the development of the software, these people are going to be directly going to be impacted, whereas end users are the people that are going to use the software. Example of end user is a customer or a specific user. So in place of developers, what term we are going to use? We are going to use the term as stakeholders. That means the developers. And end user means the customer that is going to use the software at the end.